see the feed spool comes around. It's just hot glued to that wood post, and it's attached to this brass tube. Now, in the center there, we have this little removable piece, and it's got a notch cut in it that guides the wire to the center. And another wire goes through the center hole, and I'll show you in a second what that does. It's in the next video. You'll actually see it working. And why I have to build this silly winding machine. So there it is. The wire is coming in from the right side, going through the center, and it's taking the wire from the spool that's on that rig, and it's wrapping it around. As you can see on the right side there, it's wrapping that wire around to form a guitar string made of copper. And so once you get it started, you can run this continuously for the entire length of wire that's on the moving spool there.
Well done there. Very nice.
Let me go ahead and I'll stop that share, and then I'm going to go ahead and present one more time. And I'll share my Chrome tab. Let's see. That must be it. Okay, now I'll share this. It's my computer's been on for a while, so it is particularly lagging. It's taking its sweet time, so this is going to load. Now that's the inside of the probe that we looked at earlier. You can see it a little bit better. See your 5-volt switching circuit and your power switch and all that stuff. And this was not expensive to make. Now here's something that I'm working on. This is a special transformer, and you can see that it's made with that wire we just looked at. It's made on the winding machine. And so what's going to happen here is this is going to run a magnetic flux through the core, and it's going to run it like a conventional toroidal transformer. But orthogonal to that A field, we're also going to have this secondary coil that is picking up the electric field, but it can't actually produce any voltage. However, the permeability of space-time, because there's a current flowing through it, is modified around this coil. So here we can change the permeativity of the wire that's running through the center. That's already changing the permeability. Now, what happens when you change both epsilon and mu? And by the way, this is the inside of the core. You can see it's made of 2 individual magnets, and they're basically glued together, super glued together. They are north to north face, and then it's just insulated, and it's just wound around like this. So what happens when you cancel epsilon and mu together? Well, you end up with a compound effect where the speed of light is changed in that local refractive index. And that's how we're going to use that to extract extra power, because Brownian motion has to also be affected by the local velocity c. And Brownian motion is generally random. It's uniform in all directions. So you can't extract extra energy from it, which is why Lord Kelvin said you can never draw energy back after entropy has basically scattered it. You just can't get the energy back. Well, if you change the rate flow of time between 2 physical volumes of space, now all of a sudden all the vectors towards the compressed space, or the slower, the space where the time is flowing slower, the vectors that are exactly in that direction pointing towards it are going to be stretched out longer, whereas the vectors that are orthogonal from that axis are not going to be stretched out. And so you're going to actually be able to gain the momentum difference from random Brownian motion and add it to the electrical input because it's polarized. And so you'll find that this type of device is operating off something called cold electricity, which means that it's stealing Brownian motion from the local environment and converting it. But it does rely on a delicate phase balance, and it does rely on a huge number of domain changes inside the core structure of the 2 opposing magnets. Because we're never depolarizing them, we're just flipping those individual nuclei to slow down time so that we can gain that effect inwards towards the transformer on the back EMF pulse. And it's a more advanced version of what we were talking about earlier with Brian Kelly or with the MEG. And we're not using just pure ferromagnetic elements, but we're using elements that are completely composed of a magnetized, non-conductive, non-eddy current leaking material. So I'll go back to this. This is the picture of the angle wire up close and blurry. And this is basically what it looks like, that wire that the winding machine makes. And this is what I made out of it. This is one of those other iterations as well. So this is a 14 by 14 by 14 torus with 4 interweaves. And so it's a total of 16 wires, and that means every time current passes through one path, like when it flows around in a loop, there's also another wire that's going to pick up the electric field that I can use to modify that part of the refractive index. And so it'll stack these layers on top of each other like Matryoshka nesting dolls all the way down to the very center core. And what I'll use is
Oh. We lost you.
Crap, I was just about to go and stream this on my channel. This is getting good, you know.
I've
got my AI. I've put in anti-gravity machine into my AI, which I've got running behind me here.
You got to take a picture of that coil and put that into the AI.
Yeah, look at that.
Oh shit! How long was I muted?
Yeah, you got muted there,
and I lost sound.
Jeremiah.
I was muted and I lost sound. I think I killed my audio.
Go again from the beginning.
I have to leave and come back.
Yeah, we got to go back to the beginning. That was absolutely epic, Jeremiah.
I'm gonna go live on my channel.
Definitely do.
With that, dude. Start over again.
Oh, I think he's just coming back in, and then he'll do it for sure. That's Bob Greenier's bagel coil design there that Jeremiah is essentially utilizing, and that's the 369 aspect of the vortex-based mathematics, is that bagel coil.
Unbelievable. How long was I muted?
Solid.
Were you talking?
Yeah, he was. You got to restart it all, redo it, and Jeremy's gonna stream it on his channel as well.
Yeah. You gotta be kidding. I don't know if it's gonna mute me or not.
We're live.
It's screwing with me. Oh, Mike's got something live right now, so we should go to it for now.
Yeah, start from the beginning. Just start it over again. Pretend like you were quiet for the whole thing, and just go right from the beginning.
That's fucking unbelievable.
So, for reference of everyone that's just tuning in on Jeremy's channel, Jeremiah was giving an excellent presentation of his bagel coil, which got cut off. So he's going to start over and do it again. But first, we've got Mike set up with his work. So we'll let Mike explain his, and then Jeremiah will start over with the bagel coil.
Unbelievable.
Yeah. So lately, I've been cutting some wheels on the water jet, and I got a ceramic bearing in the center. I got 4 neodymium and 2 magnets. These things spin amazing. Really, really good. So I've got the new wheel. I just purchased a new transducer. That one's about 1.5 inches in diameter. It's 60 kilohertz and 35 watts. And it's really good effects. Now I'm also putting high voltage into the motor now. So this one's set at 100 volts. DC at 7 milliamps, and the results are quite dramatic. So I'll fire it up here. You guys can see it. Wires here.
Mike, you're super quiet. I don't know if you're far away from your mic or what, but.
Oh, okay. Sorry.
There we go. Now Mike's on the mic. Sometimes it's covered.
Mike, in case you get to 88 miles an hour, what date have you set the thing to?
We gotta turn that down. Wow.
Is it too loud?
1.21 jigger.
Not you, Mike.
Oh, okay.
Or is it me? Is my mic really loud?
You came in like Zeus there.
21 gigawatts.
Thundering.
Better. Am I better here?
Yeah, that's better.
There you go.
Yeah. So yeah, the output of this is quite a bit higher now that I got the second transducer hooked up. So basically, I've been reading up a lot on what Newman was doing, and it's turning out that his theory is, I would say, correct. You got to put in a lot of voltage in, and it doesn't require current. As long as you got a big mass like that, that coil there is 1 pound of 24 gauge wire. And yeah, you can see the back EMF is quite intense. So that's a 60 watt rated bulb. So when I hook it up to the watt hour meter, it's actually 7 watts of true wattage. So I'm putting in 1.1 watts and getting out about 7 watts based on my readings from the watt hour meter. And it's all because of this little high voltage converter. So it's putting in 12 volts and getting 100 volts in. And that
So
goes
you're
directly-
getting that from the spin. You're getting that from the spin. Why could you not just use a bicycle wheel?
You could use
Good.
any wheel you want. Like this one's
Well,
quite
it's the pulsing
small.
coil that's feeding the light, not the wheel.
The coil is where the current is being generated. It's not by the battery.
The
Yes.
wheel's not doing nothing. The wheel's
Yes,
just
yes,
pulsing.
that's why I'm saying if it was bicycle wheel powered, it would eliminate any there's wires under the table claims from people, you know.
Yeah.
Yeah, this is real. This is a pulse.
Well, I mean, this thing is a super famous modification of a classic circuit called the Bedini schoolgirl circuit. It's a really simple back EMF wheel driver, and it generates power on the opposite side of where most motors do. Most motors will push and pull, so you have a continuous coupling from the rotor to the stator. And in this case, the stator doesn't exert much force on the rotor, but the rotor is then hit by the back EMF. And so right atop dead center, where it's the most efficient and closest proximity before it has a chance to move away, it gets this big pulse at the most efficient point. And the point
So
is
that Hall effect sensor is flipping the
Yeah, it's
waveform. Is it?
triggering the. I'm
it's
using
The back EMF
12 volt.
the back
I'm
EMF
using it 12.
is flowing. Back EMF is flowing out the 1N4007H diode, the high voltage diode. That's where it's going. It's going the reverse polarity. When you energize the coil, plus and minus. When the back EMF happens, it's going to be minus plus. It's going to reverse polarity. It's going to go out the high voltage diode, which is arranged in a direction for the reverse polarity.
Right. So you're also
That's
looking
it.
at something different here too. So this isn't just the BDD. This is not just the Bedini circuit. This is also an integration of Norman Wutan's oscillator, which uses piezoelectric elements to phase delay in a physical mechanical way, not just electrically, but to mechanically phase delay the signal, which allows it to interact with the external environment at a distance. And this is a very good way to basically separate the cause and effect from the input signal, where Lenz's law would normally affect and load it, and then the output pulse, where it's going to provide rotational motion and acceleration to the rotor.
Yeah, this motor's got a lot of torque.
Can you describe how that's happening, the piezo, how that's
It's basically set up in parallel with the coil. The ideal spot would actually be right behind the coil. So it's like piezoelectrics. If you apply physical pressure onto it,
using quartz? What are you using for your piezo?
it's a barium titanate.
Uh-huh.
Barium titanate, which
Like
is
just a piece of metal in parallel with the coil?
It's in parallel with the coil, yeah. But it's also getting hit with a disruptive discharge from the auto relay switch. I modified it to actually trigger very fast. So it's getting a disruptive discharge. The back EMF ricochets, hits the transducer, and then you get that flyback. And as a result, you get huge output.
We're using the back EMF to vibrate the piezoelectric.
Yeah. Instead of putting a physical stress on that transducer, I'm slamming it with a voltage.
Right. The back EMF.
Yeah.
Right. So as the magnet approaches the solenoid, the polarity is attractive, which means that the magnet actually reduces the amount of power that it takes for polarization of the core material. And then when it flips around, there's no more power supply connected to it. So the power supply built up a magnetic flux by using the approach of the rotor and its magnets to reach a magnetic saturation point that's above the electrical energy input. And then when it goes back EMF, the rotor is moving away. And so instead of going completely negative, it basically just demagnetizes completely, but the motional magnetic field, or the amps per meter in terms of the magnetic flux, is now repulsive. And so you get the extra energy on sort of both sides depending on how you run it. And it's a delicate balance. Like most of the stuff will go in losses. And a solenoid coil like what Mike's using right now is convenient, but it's really one of the worst kinds of coils to use because it has high internal self-capacitance, which is all parasitic for this circuit.
Which part has the high internal?
Sorry, say that again.
What happens if you disconnect
Where's
the
the high
battery?
internal capacitance here?
It won't run itself.
I mean,
It's
what's
made it
causing the high internal
extremely efficient.
capacitance? Is it the coil or is it the?
Yeah, the internal capacitance in the coil. Yeah, definitely. Yeah. When you
Mike,
get the
sorry to interrupt, Mike. Is this the one
yeah,
when
the
you
inductive
unplug it, it starts, it stops, and then it starts spinning in the opposite direction, and then accelerates
yeah, it
in the
does.
back?
Yeah, it works with capacitors. Yeah, it'll run down basically down to about a half a volt, and when that occurs, it slows down. It bounces back and forth, and then starts spinning in the opposite direction, and I could get about another 15 minutes of runtime with less than a half a volt.
I wonder if
Yeah,
that's
but none of
because
this
the
works without
potential
the,
across your solenoid is causing parasitic losses due to self-capacitance. Wow, hey, check this out, awesome. I wonder if it's because you have parasitic capacitic losses in your coil, and if you wound your solenoid differently, or if you didn't use something with such high internal capacitance, it would allow you to operate at a higher voltage before it started to do that.
So what? Well, more windings or less windings?
Yeah. So
It's
what
not
does
about
this
Well,
more
if
or
you
do?
want
less,
to give
they
it
have
more
to be
voltage, you
spaced.
want to give it more windings.
It's not about more or less windings. It's about the capacitance between the windings. They need to be physically farther away from each other, which means magnet wire on a tight wrap is about the opposite of what you want. You could wind a spaced solenoid and then insulate the layers, or you could wind a totally different type of coil, like, say, a pancake or something with spaced windings, and do multiple pancakes stacked on top of each other in order to get rid of that problem. Yeah, you'll notice all of Tesla's oscillators, all of his secondary coils and his extra coils are spaced out, much unlike today's Tesla coils. He always uses at least double spacing or triple spacing to the thickness of the wire between conductors, and that's extremely important.
Yeah, I've been noticing that people are saying that we should space the coils, not understanding how that's making what role it plays in your efficiency.
Yeah, back in the day, there used to be something called a weave wound coil, and it was a zigzag back and forth three-dimensional coil where most of the wires were kind of semi-orthogonal to each other. When they crossed over, they crossed at a narrow point, sort of like a star coil, but along the other axis, built tall instead of wide. And that significantly reduces the self-capacitance and allows you to capture this back EMF effect and the local refractive index change much more effectively without the losses.
So
now that we got Jero, he can talk on this because that's how his coils work.
So spacing a coil, it helps lose the inductive reactance.
Right, it gets rid of it, almost.
But why would you want to get rid of the inductive reactance?
Because it's parasitic.
How? How's that?
What?
It slows down the signal, which reduces the maximum volts per meter of the radiated field.
Mike, what are we doing with this thing? Why are we building this, and what does it do?
Well, I'm testing out the theory, to eventually get it to the point where it can recharge itself and maintain its own power source, right? So it will eventually be looped. I'm just trying to get the science down first, right? And I've been working on this for 5 years, and then all of a sudden I figured try to hook up a transducer to it, and my gains quite a bit higher. So I knew I was onto something, and I just kind of went with it. It's just a lot of it's experimentation. You just got to get on the bench and do it, right? Try different ideas. I've always got new ideas running through my head how to improve this thing, right? But as far as efficiency is concerned, I really feel that I really think that
I can't hear anything he's saying. Can any of you?
No, yeah, Mike, I think you're covering your microphone on your cell phone the way you're holding it. That happens to me when I'm recording sometimes. And welcome, Gerald. Thanks for joining.
Well,
can you guys hear me now better?
Yes, we can.
Okay, yeah, it was my headset was dying, so I had to switch it. Yeah. I think. So I think it's Newman was really onto something very correct as far as